Okay, we're first going to go over the relative dating of your rocks. This was the one that with the law of superposition, oldest is on the bottom, youngest on the top, law cross-cutting, law included fragments. Everything from Lab 21, which was interpreting geological events, and Lab 22, which was matching your rock layers, along with using your reference tables page 2, 3, and 8, and 9. So let's go over the questions that relate to relative dating. In your review book, page 280, question number 1. According to the generalized bedrock geology of New York State in the Earth Science reference tables, what is the geological age of the bedrock found at the surface of 43 degrees 30 minutes north latitude by 75 degrees west longitude? So that means that's a reference table. Page 2 we're going. Nope, page 3. So I'm on page 3 of your reference table. My longitude is 75 degrees. My latitude is 43 degrees 30 minutes. 43 degrees, 43 degrees 30 minutes. So I need to see where those two intersect. And where I see where those two intersect, I'm just south of Old Forge. So I need to know what's the age. So I'm looking at the symbols that are here. I have to go down, find that symbol right here. Middle Proterozoic is my answer. Number 2. Which area in New York State is located on rock formations that contain large amounts of salt deposits? I'm back onto reference table 3. I'm looking for salt deposits. If I'm looking, salts come up with Silurian. Silurian, I'm looking for my symbol. Find my symbol, I come over here, back to the map. That's going to be Syracuse. The following diagram represents a cross-sectional view of a portion of the Earth's crust showing sedimentary rock layers that have not been overturned. If it hasn't been overturned, the oldest is, you're right, at the bottom, and the youngest is at the top. The letters identify the specific layers. Which rock layer is probably the oldest? We just talked about it. It's going to be the one on the bottom. So A. Number 4. The following diagram shows a portion of the Earth's crust. What is the relative age of the igneous rock? So I need you back on the diagram. If I have contact metamorphism, that means the rock was there before your igneous intrusion. If I do not have contact metamorphism on it, that means the intrusion happened before the rock. So if I'm looking, I have contact metamorphism on the limestone, but I do not have it on the shale. So the limestone's got to be older than the intrusion, and the intrusion's got to be older than the shale. So my answer's got to be it is younger than the limestone, but older than the shale. Number 5. Suppose you are examining a section of sedimentary rock. What evidence could you observe that would support the principle of superposition? Law of superposition or principle of superposition, same thing. Oldest on the bottom, progressively younger as you go up. So what you could do is you could look for index fossils, or you could actually do radioactive decay dating. So you could figure out what rocks are older, which ones are younger. Number 6. What is the age of the surface bedrock at Niagara Falls, New York? Okay, get back to your reference table, page 3. I find Niagara Falls, I look for the symbol. I come down here to match the symbol, and I notice it's Silurian, just like Syracuse. Number 7. The following diagram represents exposed bedrock. Which geological event occurred last? So if I'm looking at them, I have all my sedimentary rocks deposited. They're all interfolded, so the fold happened. Then if I look at it, then I must have faulted because all the folds are offset. All the layers are offset. The last thing that happened is my igneous intrusion cuts through. because it cuts through everything, the faults and the folds of all the rocks. So my answer is the intrusion of A. Number 8. The simplest way to correlate exposed rock layers in the same general vicinity when they contain no fossils is by, this is one that in your notes I have as walking the outcrop. I get there, I'm following along. That's going to be number 3, following the continuity of the layers. I'm going to walk right along 81 where it's exposed. Number 9. The following diagrams represent the rock layers and fossils found in 4 widely separated areas of exposed bedrock. Which fossil appears to be the best index fossil? Now, if it's an index fossil, I want it widespread, so I want it in each of the different outcrops. I want it short-lived, so that means I want it in only one layer. If it's in all the different layers vertically, it's lived too long. So if I look at my first one, my spheroid. My spheroid is in each of the outcrops. The problem is, if I'm looking at outcrop B, it lives too long. If I look at number 2, my crinoid stem is not widespread. It's only in location D. If I'm looking at my ammonoid is in each of the outcrops, but only in one layer. So that's going to be my best answer, because if I look at 4 is in all the outcrops, but if I'm looking, it's in too many of them vertically. Number 10. Describe 2 essential characteristics of an index fossil. This is widespread and short-lived. Number 11. In a conglomerate rock sample that is composed of limestone particles cemented together by calcite, what is the oldest part of the rock sample? Well, remember, we had talked about this before when we did rocks. The particles that make up the conglomerate came from pre-existing rocks that have been uplifted and weathered and eroded. They have to be the oldest thing. Then you cement it together and eventually it hardens and you get a conglomerate rock. So the oldest are your rock particles. Base your answers questions 12 through 14 on the following diagram. Number 12. The disturbed rock structure shown is probably the result of, if I'm looking here, they've been offset. It's because they've been faulted. The layers are still flat, so it's not folding. Number 13. Which is the oldest sedimentary rock in this diagram? So remember, oldest is on the bottom. My oldest is actually igneous. So I want to go just above the igneous, and here is the conglomerate. So conglomerate's got to be my oldest. Rock layer B is the same age as layer. So if I look at rock layer B, here's the conglomerate 1, 2 above. Conglomerate 1, 2 above. It's letter F. So you're correlating again. Number 15. The following diagram of 3 profile sections show fossils deposits W, X, Y, and Z found in widely separated locations. Which would be the best index fossil? I want it widespread, so I need it in locality A, B, and C, but I only want it in one layer vertically. W is in too many. X looks good. Let's see what Y is not here. Y is only in location B, so that's not going to work. And Z is in too many vertically. So my answer is definitely X. Number 16. The following diagrams represent cross-sections of 3 areas of exposed bedrock approximately 100 kilometers apart. What would be the best method of correlating the rock layers of each area? I'm going to be looking for index fossils. Remember, if you're trying to do matching rocks or correlating rocks and you're far apart, you're looking for index fossil or key beds. Key beds, remember something such as volcanic ash. Number 17. Why can layers of volcanic ash found between other rock layers often serve as good geological time markers? That's number 4. Because they're rapidly deposited over a large area. The wind is going to carry that ash, so it's going to go further away. We talked about it when we talked about rocks. That Mount St. Helens, some of the ash was in the air for 4 years, which is nothing geologically, and that it was actually found in the Midwest in the United States. Number 18, according to earth science reference tables, which rock is most likely the oldest? So what I need you doing is I need you looking at the fossils, the mastodon, the trilobite, the flowering plants, and the dinosaur footprint. So you're on page 8 and 9. Your mastodon is relatively young, so that's not going to be my answer. It's not can't be the oldest. If I'm looking for flowering plants, well, flowering plants are older. Then if I'm looking at dinosaurs, dinosaurs are even older, but the oldest is going to be my trilobite, which is back in the Cambrian period. So your answer, trilobites. Number 19. The best basis for concluding that a certain layer of shale rock in New York State was deposited at the same time as one in California is that they both, your answer is, contain similar fossil remains. Number 20. Why might it be more likely for a fossil to be found in sedimentary rock than either igneous or metamorphic? We had talked about this when we did rocks. Remember, igneous, I'm melting, so I would destroy the fossil. Metamorphic, I'm adding heat and pressure. I'd also destroy the fossil. So the only one that's not destroying the fossil is your sedimentary rock. Question 21. You are searching for fossils in the surface bedrock in Elmira, New York. Why are you unlikely to find dinosaur fossils at this location? First thing, reference table page 3. Gotta find Elmira, New York. Elmira, New York, you can see the symbols in ... Come over here, it's Devonian. So I know Elmira is Devonian. Now I gotta find dinosaurs. When did the dinosaurs live? I'm on page 8 in my reference table. Devonian, I don't have dinosaurs. Dinosaurs don't come about until when? The earliest dinosaurs, Triassic. So you would not expect to find dinosaurs in Elmira. Number 22. During which time was the majority of the exposed bedrock in New York State deposited? I'm back onto my reference table, page 8. Remember this one, New York rock record. Majority of it, so if I have the black line, that means I have rock record. If I have that grayish black, that means I have sediment record. So if I look at it, majority of it's down here, from my Cambrian through my Devonian, maybe early Mississippian. So if I'm looking to figure out what time, my options are Precambrian, no. Paleozoic, which would take in this time, looks good. Mesozoic, not looking so good. And my Cenozoic, not looking good. So my answer is going to be Paleozoic is my most. 23. Rocks containing fossils of the earliest land plants could most likely be found in New York State bedrock near. So I'm back to my reference table. Earliest land plants. So you're scrolling down, earliest land plants and animals, Silurian. Back onto my reference table, page 3. I'm looking for Silurian. Got to find my symbol. That's going to give me Niagara Falls. It's going to give me Syracuse. So I'm going to go with Syracuse. Number 24. Approximately how long ago were the tectonic mountains uplifted? So this one, I'm on page 9 of my reference table. Alright, tectonic orogeny, which is mountain building. So this one I'm reading over. It's during the Ordovician period, which is 444 to 488 million years ago. So I need something in that range. So the only one in the range, 470 million years ago. Number 25. According to the geological history of New York State in the Earth Science Reference Table, what is the estimated age of the Earth as a planet in millions of years ago? This you're going to need to know when we do astronomy. So I come over here, page 8. All the way at the bottom, it says estimated time origin of Earth and the solar system. So that's 4,600 million years ago, also known as 4.6 billion. Number 26. The geological timescale has been subdivided into a number of time units largely on the basis of. So I'm going back here. We talked about it in the notes. In the beginning, I had what? Soft body organisms. They don't fossilize really well. Then I got into hard body organisms. If I'm looking at what separated my Paleozoic from Mesozoic, remember, mass extinction. What separated my Mesozoic from a Cenozoic? Mass extinction. So it's going to be in the fossil record. So my answer is going to be fossil evidence. Radioactive decay is going to give me the dates, but is not what the geological timescale is separated based on. It's all based on mass extinction. Number 27. Which line is the best representation of the relative duration of each of the geological time intervals? So if I'm looking back on page 8, most of my time is Precambrian. Then next, Paleozoic. Next, Mesozoic. And a very small amount is Cenozoic. So I'm looking at number 4. Majority of my time, about 4 billion years, is Precambrian. Then a smaller Paleozoic, even smaller Mesozoic, and then the smallest Cenozoic. Base your answers to questions 28 through 32 on the following diagram. Which is the most recently formed rock? Most recently formed rock is going to be on the top, yes? So if I'm looking, the letter that's on the top is letter A. An unconformity is located between, remember, unconformity, I'm looking for what? So a gap in the rock record. Something's missing. On your drawings, it's that wavy line. So that wavy line is actually between letters C and D. Number 30. The conclusion that the limestone layer D is younger than the basalt layer E is supported by the evidence of. So if I come down here, notice I have contact metamorphism on all these layers. I do not have any contact metamorphism on D. So my E is what created the contact metamorphism. So I must have had all these, then E, then erosion, and then D. So contact metamorphism is my answer. Make sure you're looking at those things when you guys take a quiz or a test. Look for the contact metamorphism. 31. The last event before faulting occurred was the formation of. So if I go back, all these layers are deposited. My last one that is offset by the faults is letter D. So my answer is formation D. Number 32. Which must have most recently preceded the formation layer D? So if I'm looking at layer D, so preceded means comes before. We just talked about how the igneous intrusion happened before D because it has no contact metamorphism on it. The other thing, faulting can't be the answer because D has been faulted. So you had to have through D before you faulted. Orogeny is mountain building. There's no mountain building here because if you notice, your sedimentary rock layer is still horizontal. All right. No uplifting. That usually has to go with erosion. So the last thing that you're going to bring it to the surface. So I'm going to go with intrusion is your last one because you are missing the contact metamorphism. Number 33. An unconformity between two sedimentary layers is most likely produced by. I need to bring it to the surface. I need to erode it, submergence, and deposition, which ironically is on page 286 in the diagram right in the top. So remember, unconformity means there's a gap in the rock record. Something's missing. Number 34. Because the chemical, physical, geological, and biological characteristics of nature remain the same throughout time, we can interpret the past and you can predict natural hazard events. So you're looking to see what's gone on in the past, how that affects each other, and that's going to tell you what hazardous events are going to happen. That too is in your reading on page 286. So we use those things to help us try to figure out when we're going to have an earthquake, when we're going to have an eruption. Those are things that we talked about earlier this year. Number 35. Fossils are rarely found in the Precambrian rocks because at that time, go back to your reference table. Precambrian, remember, it's this area, this gray area. If I'm looking Precambrian, what? They're my soft body organisms. Something like a jellyfish doesn't fossilize well. So your answer is 2. Few life forms had hard parts. Number 36. The present is the key to the past. Explain what this statement means in the context of the geological history. So what we're doing is we're looking to see what's going on right now, weathering, erosion, uplift, plate tectonics, plates moving, shifting, folding, faulting, and then we take that information and we apply it to the rock record to figure out what happened back then. All right, so that's it for your relative dating. I'll be back on absolute.